One other thing that I want you to remember about x sub I is that in order to find it, remember we used this formula? So we took our beginning value, which was a, and then we added the width of each rectangle, because they were all the same width, times I, which was the number of rectangles. Okay, so let's do some. Alright, so on this example, just like we did in class today, now here's the difference. We're looking at the area from A to B, and when I see these numbers, I'm going to be able to plug those in at the end by finding f of B minus f of A. Alright, so actually, before we even do that, let's just follow the directions on this and actually graph it and look at the area under the curve. So I'm not even going to talk about that yet. Let's back up. I'm going to graph it. So after I graph it, I note, hey, it's nothing more than a triangle. And I know the formula for my triangle is 1/2 base times height. And I'm finding the area from 0 to 2. I guess I got lucky in that it actually hits the x-axis at 2. And I also got lucky in that it hits the y-axis at 4. And so all I have to do is plug in the numbers. 1/2 of the base times the height gives me a grand total of 4. And again, on this next one, I draw a graph. Remember, absolute value functions, of course, look like a V. This one has a negative slope, so it's opening down. The y-intercept is at 4. The slopes would be +1 and -1. Remember, there's an imaginary 1 in there. So it hits the x-axis at -4 and +4. And so again, I'm finding the area of a triangle. This time, my entire base is 8, and the height is 4. So I get a grand total of 16 for the area between my graph, my function, and the x-axis. One other thing to note that I forgot to mention is that for my integral, I was in fact going from -4 to 4. So I was in fact finding all of the shaded area between those two x values. So everything between those two x values is the triangle I have shaded above the x-axis. Always want to check what your integration bounds are so you know how much you're actually finding the area of. On to number 3. So notice on this next one, I don't even have a bounded region until I pay attention to the bounds on my integral. And so I want to go from x equals 0 to x equals 4, and that's the stuff directly underneath that is where I'm finding the area between my curve and my x-axis. And so again, I go, wow, Torres, are these all going to be this easy? Do I always get a triangle? Of course, the answer to that is no. And so my base would be 4, and my height is 2, and so I get a grand total of 4 units again. So this next one, you need to make a correction. I honestly don't know where that equation came from or where that integral came from, but I want it to look like the one that I have written here to the left. And notice, first I'm going from -2 to +2, so I want the area in between those two x values. And if you remember, this is the formula for half a circle. Happens to be the bottom half because of the negative symbol in front of it. If that wasn't there, it'd be the top half. And fortunately for me, it happens to hit at -2 and +2. And so I want the area between the curve and the x-axis. So I have a half a circle. And so now on this one, see, I told you they wouldn't all be triangles. I have to do 1/2 pi r squared because I'm doing half a circle. And of course the radius is 2. So I'll end up with 2 pi is my final area. And it will be negative because it's below the x-axis. So very important that I remember that. I'll change that to a negative. Okay, so moving on to the next piece. Now, going to be very important here. So I have a graph of f of x, and I'm trying to figure out the area between the graph and the x-axis. And I need to look at the boundaries. And I say, okay, I want from 0 to 2. So everything in between there that also falls underneath the curve. And so then I have to decide, is this a shape I recognize? Well, it actually is a trapezoid. If you remember your formula for area of trapezoid, I hope you remember all these area formulas. And you thought geometry wasn't important. And so now when I'm looking at the bases, remember the bases on a trapezoid run parallel to each other. So there's 1, and there's the other. And then the height is running the other way. So when I plug in numbers, my bases are 1 high and 3, and the height is a 2, so I get a grand total of 4 for the first one. So on letter B, again, I first take note of the x values that I'm looking between, so 0 and 5, and all the stuff that's between my function and the x-axis is shaded in green. And again, I double check, see if it's any particular shape that I know. This one is not, because it's a pentagon, so I don't have any formulas for irregular pentagons. So I can use my geometry skills and divide it up. So I'm going to cut here. I already knew this area right here was 4, because I found that in problem A. And so I'm just going to find the stuff to the right of that, which happens to be another trapezoid, only this time the bases are running horizontal. So my two bases, the top one is 1, the bottom one is 3, and the height is 3. So I get a grand total of 6, and I have to add that to the stuff on the left. So the area under the curve between 0 and 5 is 10. I bet you're almost ready to take the training wheels off and try the next one by yourself. You can pause the video if you like and actually do this one by yourself. I'm going to talk it through, so I'll be here when you get back, talking. So again, I notice it's a triangle, so I can use my triangle formula. The base is 2, the height is 3, and my answer, I know, is going to be a negative because the area is under the x-axis. It falls below. So I get a grand total of -3. And then last but not least, I can do from 0 to 9. So of course, I've already found 3 pieces of this, and there's no need for me to rework those. So the only thing I have left to do is this from 7 to 9. And again, it's a trapezoid, so I can use the trapezoid formula. Remember, the bases are now running vertically, so they are 3 and 2. and then the height is running horizontally. That's 2. So I know this looks like a 3 down here, but honestly it's not. So my grand total is 5. And now remember, that's going to be a negative since it's below the x-axis. So now I'm going to add up the 4 that I had for part A, plus the 6 for part B. Well, I introduced a new 6. I guess I could have just added part B, which was 10. And then I'll add the negative 3, the pink piece. And I'll add the negative 5, the funky green piece. And when I add all of that together, I get a grand total of 2. And so remember I warned you earlier that some canceling out was going to happen if we had areas above and below the x-axis. Because of that, some of it is positive and some of it is negative effect. So it sort of misleads us on what the actual area is, simply because some of it cancels the other out.